Good afternoon, everybody. Today, we're going to talk about the last question of IOI 2021, which is register. So the problem is like this. You basically have a set of memory cells, which are called registers. Each number is basically in the register cell is represented in some kind of 2 to the power of n configurations. So you are given a set of instructions you can use. Basically, you can move, you can store, and you can add. Then you can have a bunch of bitwise operations. Right? You can shift left, shift right, basically a bunch of bitwise operations. The question they gave you is, if they give you an array of integers, right, that are saved in the register, how could you find the minimum or maximum value? And then how can you sort the array? So that is the question. If you think about it, the only operation you need to figure out is you want to do comparison. In other words, if you have number A and B, if you can do this operation, if you can find is A less than B, or in other words, if you can find minimum of A and B, or you can find the maximum of A and B. If you can do any of those operations, then that's easy to do, right? So that means task 1, you have C0, C1, all the way to Cn minus 1, right? So you just kind of bubble from left to right, right? So every time you do the comparison and you move the minimum number to here, you continue doing the comparison, right? So task 2 is basically a sort, right? So you just do, obviously you can do bubble sort, but that is kind of stupid, right? Just do, for example, there's a manual algorithm, we will know, right? You can do divide and conquer, right? Or to do divide and conquer. Okay, for example, I mean, there's many other ways we will know how to do sort. So the key is how to do this operation using bitwise operation. Basically how to do minimum using bitwise operation, right? That's the question. So this is actually a standard problem. So here is one of the answers in Geeks for Geeks. So there's this operation has a complexity of O of 1. There are some other operations you can have a complexity of O of n. So let's assume x minus y is in the minimum and maximum, the range of the minimum maximum. This is the operation to do bitwise operation to do to find the minimum value. Basically, if you have x and y, take y plus this thing, right? This thing is you do x minus y, and you do an AND operation right? Then you take the x minus y, you do a shift to the right. Okay, so if you look at the problem, we have add, right? So we have add, right? So we have add. So we know how to do add. Just away for a second. We know how to do add. There's and, right? So we know how to do. We know how to do and. Shift. We know how to do shift, right? There's a shift to the left and a shift to the right. Negative. How do I do x minus y? Okay, so then let me give you another instruction, which is in Stack Overflow. You know, right? Those are the places you can find good answers. Gigs for gigs, Stack Overflow, you know, those kind of places, right? So x minus y, so a minus b is basically is a plus negative b, right? What is negative b? It's x over b plus 1. Okay, so then we know how to do this. We know how to do x minus y. Right? Then it becomes straightforward. So then if you put all those together, that's how you do this comparison, right? So done is in O(n) of 1, right? This comparison can be done in O(n) of 1. So this bubble is O of n, right? So then if you want to do a sort, right? So it's n log n, right? So now that's basically the answer. The only difficulty is to figure out how to do minimum use bitwise operation. You can look at the standard result, standard answer, or you can look at, I mean, when I say standard, so I mean official answers, or you can look at many other answers, solutions. They're all like some kind of variant of this, right? So for example, here I give you one of the result, one of the solutions, you know, basic bunch of operations, right? So, so you can take this and basically try to solve it by yourself. Okay, that concludes the solutions for IOI 2021. And frankly, IOI 2021 problem was not that difficult. It's not the most difficult one. Frankly, it's much easier than some of the IOI problems in previous years. So go ahead and today's homework is to go ahead and finish this register. If you did not finish the previous dragon problem when you're in finals, so go ahead and finish that as well. So then we will meet again for next season after summer. So during summer, I really recommend everybody go finish Benjamin Chee's U-cycle guide, right? If you want to get a good result, don't satisfied to finish the platinum level class. You got to finish the advanced class in Benjamin Chee's U-cycle guide. Okay, the U-cycle the advanced level actually goes beyond even the IOI. Okay, but they're really, really useful. Okay, so for the advanced level, assuming you have finished the platinum, if you have not finished the platinum, please go finish the platinum class. The advanced level, talking about a couple of things. Talk about the advanced data structures, the wavelet tree and segment tree bits, persistent data structures. Remember persistent data structure, I think the class, the platinum problem 2 or 3 years ago when we were trying to solve the robot, how to build a robot with different parts. Each parts have different different cost. That was a persistent data structure problem, right? You build a persistent data segment tree for each robot that you're building. And trips, we talked about one of the problem in last year in the just past seasons. USACO Platinum can be solved much easier if you know how to do trips. Even though trips is beyond the IOI. Then convex, the convex Hall kind of problem, right? And the slope tricks. Then bunch of graph problems, Euler tools, BCCs, strongly connected components, deletions, Euler formula. Remember there was a Euler formula problem, and there's a linked tree cut problem. Then a little bit more about dynamic trees, dynamic programming, and then flows. I don't think a flow is above IOI requirement as well. I don't really remember we used the flow to solve any problems, but it's just nice to have it. Then Fourier transformation. This is very useful. Faster Fourier transformation, and that is very useful. And then, hey, a bunch of bitwise operations. Okay, those are the things like you guys to go to study as much as possible. I would go pretty much by this order, figure out the data structures, complex data structures, remind yourself with the convex Hall DP, and study more about the graphic, then understand the flow problems and understand how to do fast Fourier transformation. Okay. One thing I forgot. If you are, one of the questions come up in the chat was, hey, how do I study more on the bitwise operation? There was a bitwise operation in the Platinum level, if I remember correctly, Platinum level class, and you can look at this on that. And then I also give you a collection from the Stanford class, computer science class, which has all those things about how to use bitwise operation to do many different things. Okay, so go study those. That will be interesting. Right. So, for example, the problem we're trying to do was here, right? Compute the minimum maximum using bitwise. Right. That was the one we're trying to do. Yeah. Sorry. That was this is the one we're trying to do here. Right. This one is faster. This is O of 1. This is O of n. So that is it. So this just to summarize, for this season, right, past the season, we went through all the Platinum competition problems, and then we went through IOI 2021. Okay, so in the summer, hopefully you guys have a wonderful summer, and go study the advanced class of Benjamin Chi, Benjamin Ching and his game, right? Class, okay, and then start from next season. We will do it again, right? So you guys have a wonderful summer, and good luck.